Okay, exponents and logs, or exponent laws. Eventually we get logs. Remember the language of a power. A power contains a base and an exponent. That language will become very significant for us in the week or so to come. What's the rule when I take two bases that are the same and I want to multiply them? What do I do with their exponents? You add them. So that's x to the m plus n. What about a power of a power? Right. You multiply those. So that's going to be x to the mn. What about a power of a quotient? No subtracting yet. That's the quotient law over here. How does m come in on the x and the y? It multiplies. So x to the m, y to the m. Quotient law, that's what Moses was just talking about. If I have x to the m divided by x to the n, what do I do with the m's and n's? Subtract them. So that's x to the m minus n. What if I have the power of a product? Times them. So I have to times the bases together, but what power is the x going to get? What power is the y going to get? The same. So I'm going to get x to the m and y to the m. Now, something that we messed up, and I know that if I have x plus y to the m, can I simplify that? That's not written in your book. No. X plus y to the m will actually have to be FOILed out. You actually have to FOIL that baby out. It's not fun. We will learn a shortcut for that in a later chapter. Integral and rational exponents. What are we supposed to do actually with negative exponents? Apparently negative exponents are bad. Pardon me? Do something with the reciprocal. What would it look like? It's not going to be 1 over m. The x to the minus m will become positive by going 1 over x to the m. It moves down into the denominator position. So it's not quite reciprocal, but it is moving into the denominator. Now I've got a blank, and then I've got x to the something m. What goes in the brackets that are missing? X to the who? Is it x to the n? It has to be exactly equal to this. How does the n have to be written? Where is the n right now? 1 over n. X to the 1 over n times m raised to the power of m, raised to the exponent m. Another way of writing that would be to put the m on the inside, so x to the m, and what goes outside? So that's x to the m, for lack of a better descriptor. That's an m on the inside bracket. What goes outside? N where? 1 over n, or just plain old n? 1 over n. So we have to maintain that fraction arrangement. So if we slide down, we get to use these exponent rules right away. And we want to do these 3 questions to write them without brackets and positive exponents. Can you try that? Here are the answers for the shifting of signs and dividing. We're going to flip over the page and take a look at a few more examples. So again, we have the results for these 3 questions. I've tried to track my work. If you've missed this class, hopefully it makes some sense. Otherwise, come and talk to me. So I know that 5 to the 3 is 125. Now you may remember that, or you can work it through on your calculator, but I can totally replace the 125 with 5 to the 3. Now, how does the exponent of 3 and the exponent of 2 minus x hang out? I don't want brackets anymore. They what? They multiply. So now I have to multiply 3 times 2 minus x, which is 5 to the exponent 6 minus 3x. So all those skills come and play in the work that we're doing. Our rules for exponents, for powers, have to be in our heads so that we can use them. The numbers 16 and 81 as it relates to 2 and 3. That's weird. 2 to what power is 16? 2 to the power 4 is 16. Okay. And 3 to the power of what is 81? We can check it out, right? 3 times 3 is 9, and 9 times 3 is 27, and I hope 27 times 3 is 81. So 3 to the power of 4 is equal to my 81. Now what can I do? The 2 to the 4 and 3 to the 4 are going to replace my 16 and my 81. 2 to the 4, 3 to the 4 to the power x plus 5. I want this to look beautiful. Yeah, Emmanuel. Nope. It's 2 to the power 4 over 3 to the power 4. I have to do a full scale replacement of 16 and a full scale replacement of 81. I want this to look better. Like, this is terrible, but it can look better. What can I do? How about get rid of get rid of the 4s? The 4s don't cancel. Can you take it out? What would it look like with the 4s taken out? So the final answer here becomes 2 over 3. I need brackets of some sort, square brackets or round brackets. I don't care, but 4x plus 20. Now, where does that skill come into play? Turn the page over again. So Sarah's going to end up cube rooting both sides. And we understand that a cube root and r to the 3 undoes one another, so I isolate r. What other button could I use on my calculator so that maybe I don't have to rely on math all the time? I've got a hint there. The power button. Yeah. we actually are going to take both sides of the equation and raise them to the power, raise it to the exponent, sorry, I gotta watch my language, raise it to the exponent of 1 over 3. So what's the rule here? R to the 3 to the 1 over 3. What happens? What happens with the 3 and 1/3? They cancel because 3 times 1/3 is R, and that's how I'm going to isolate for R, and I can try it on the statement as well.